We're going to talk a little bit today about Pythagorean Theorem. You will have some other resources that will help you understand this more fully. This is a very important topic when it comes to Math 2. So we're going to be doing the basics here. This is an 8th grade solely topic, and then it moves applications into Math 1, and you really have to understand it in Math 2 to be able to find all kinds of angles in trigonometry. So it's really important. So Pythagorean theorem is a theorem that proves that a triangle is a right triangle. So this only works for right triangles. That's important to know. Some right triangles will have the little box to show you that's a right angle. Some of them will not. You have to use this to prove it. So you have two legs of a triangle. That's what we're going to call A and B, and they can be reversed. It doesn't matter which one you call A and which one you call B. But C is always the hypotenuse. The hypotenuse is the longest side of the right triangle, and it's always opposite of the right triangle, where the right angle is. All right, so our formula is A squared plus B squared equals C squared. That's how we see if it is actually a right triangle. So let's jump into the first example. So our first example is a triangle that has a leg of 11 and a square root of 23, and then we don't know the hypotenuse. So we're going to plug it in and find it. So we're calling A 11, so we're going to plug in 11 and square it, plus the square root of 23 squared equals C squared. Then we're going to simplify. Well, 11 squared is 121. Anytime I take the square root of something and square it, it undoes the square root, so it's just actually 23 is equal to C squared. 121 plus 23 is 144. So I know that C squared is 144, so basically what is the square root of both sides to get just what C is? I know that C is equal to 12. So then I know that my hypotenuse is 12 units, whatever the units are, inches, centimeters, whatever it may be. So we have some special formulas that will work, always that give you like certain cases, like 3, 4, 5 triangle will always give you a right triangle. If you have sides 3, 4, and 5, it's always going to work. So you're going to see some of those special rules. So let's go on to B. I want you to try this one on your own. Pause the video and then come back and check. All right, so when we work this one, we see that we have a radical here, a square root of 73. It's not a perfect square, so we can actually leave it as square root of 73. It could be a positive or negative if we're talking about something that was not a shape, but obviously you can't have a negative square root of something, so we don't have a negative here. This is a square root of 73. If you put this in your calculator, you're going to get a decimal. It's going to go on forever. You'd have to round it. So this is the most precise answer as a square root of 73. Sometimes they'll ask you to round it or to simplify it down to the nearest tenth, so follow whatever directions. But this is the most accurate answer since it is not rounded. All right, let's look at another example where we know the hypotenuse and we know one of the legs, but we don't know the other leg. So we do the same thing. We still start with the A squared plus B squared equals C squared. And we plug in what we know. We don't know what A is, so we're going to leave it as A squared. We do know what B is, 7 squared, and we know that 10 is C, and we're going to square it. Then we're going to simplify. A squared, 7 squared is 49, 10 squared gives you 100. Then we're going to subtract 49, 49, you get 51. A squared equals 51. Then take the square root of both sides, so you get A is the square root of 51. And you can leave it as that. Now, the next thing we're going to talk about is how you can use this to prove that something is or is not a right triangle, but also what type of triangle it is. If it makes a triangle, it's going to have 3 sides. Obviously, you learned in 7th grade that 2 of those sides have to be bigger than the 3rd side for it to actually make a triangle. So these will make a triangle, however, what type of triangle? So if they don't make a right triangle, they either make an acute triangle or an obtuse triangle. So there's a rule. And so I've given you all 3 sides of this triangle. We just don't know. We're going to see if it's a right triangle. So we'll plug it in using the formula A squared plus B squared equals C squared, and we're going to plug in what we know. So 8 squared plus 9 squared is equal to 11 squared. 8 squared gives us 64. Plus 9 squared is 81. 11 squared is 121. When I add 64 and 81, I get 145. And 145 is not equal to 121. It's not equal. So we know it's not a right triangle. But what type of triangle is it? Well, when the a squared plus b squared side is greater than the c squared side, you actually have an acute triangle. So think about what that means. So that when the a side and the b side, that means it brings together, when they're bigger, it brings together the angle more here. So you have an acute triangle. So that's what you have to remember. It's kind of opposite of what you think. So let's try the other one. The a is 15, so 15 squared plus 36 squared equals 4 square roots of 99 squared. And we haven't seen a lot of these before. You see a lot of these in math too. Don't be intimidated. It's very simple. You literally just take whatever the square root of 99 is and you multiply it by 4. That's what's happening there. So 99 is not a perfect square, but we're squaring something. So it's going to make it simple in just a second. So 15 squared is 225. $36 squared is 1,296. And then this squared actually gets rid of that square root. And you can use your calculator to do this. If you put this in, it ends up being 1584. So we're not worrying about actually how to computate that. It's just you can use your calculator for that part. So when we add these together, we get 1521 is equal to 1584. And we know that is not true. But the c squared is actually bigger. So when a squared plus b squared is smaller than the c squared, meaning the c squared side is bigger, this is an obtuse. It actually made that angle wider. So it made it wider here across from the hypotenuse. And that's why it's an obtuse. Okay, because it was longer. Its c is longer. All right, so let's talk about an application. So here's an example of a problem. This is a 3-star. This is an application problem, and it's a multi-step problem. So I've given you a trapezoid here, and I've given you some lengths. But notice that I have a little area marked off. So this marked off area is actually a right triangle. So we're first going to find out what this height is to help us figure out what the area of the trapezoid is. So we're going to have to use the Pythagorean Theorem first. So a squared we're going to use as our unknown. We don't know what a is. We'll call this one a. And we'll call this b. And we're calling this c. So a we don't know, so a squared is left. B is 8, and we're going to square it, is equal to 10 squared. So then we're going to simplify and find out what a is. So a squared plus 8 squared would be 64. 10 squared is 100 minus 64 minus 64. So you get a squared is equal to 36. We're going to take the square root, both sides. So we get a is equal to 6. So now we know the height is 6. This is the height of our trapezoid. And now we're going to use our formula for a trapezoid to find out area. And that is base 1 plus base 2 divided by 2 times the height. And we're going to plug it in. Where our base 1, we can call maybe this top piece base 1. It doesn't matter if we call 6 or 12. We have 6 plus, now, not just 12, but 12 and 8. So this whole thing at the bottom is actually 20. So 6 plus 20 divided by 2. And then we're going to multiply it by our height of 6. So when we simplify that down, we have 26 divided by 2 times 6. Or that's 13 times 6, which equals 78 units squared, whatever our units may be. So this is just a brief introduction. There is another little activity you're going to do with Pythagorean Theorem, so you know it. And then you'll have some practice on Pythagorean Theorem.